Hello everyone. The paper presented today is wideband modeling of power silicon carbide MOSFET module and conduct EMI prediction of the NVDC railway electrification system. The silicon carbide MOSFET in NVDC transportation electrification system features a faster switching performance while simultaneously bringing more significant EMI issues within the rolling stock, substation, and radial disturbance into space along with the catenary and tracks. Due to the necessity to involve both transient characteristic of power semiconductor device and the strain parameters of all equipment in the analysis of EMI, it is considerably challenging to perform a wideband device simulation on traditional commercial software for such a complex system with enormous trays and stations. A computational efficiency method for wideband modeling and simulation of the NVDC high-speed rail system for assessment of conduct EMI during the project design stage is proposed in this article. The physical characteristic of the semiconductor devices, characteristic parameters of the MOSFET packaging, and converter topology are all taken into consideration to provide not only the accurate system-level performance of the system, but also an insight into the high-frequency characteristics under different operating conditions. The calculation burden is alleviated by the hierarchical circuit partition architecture based on frequency domain time domain transmission line model and the northern equivalent parameter extraction of each MOSFET module to split the whole system into several smaller subcircuits in terms of matrix size. And a fully parallel implementation of the NVDC system is carried out on GPU. The developed program is used to study the case of Xinjiang high-speed rail system topology, which is compatible to be modified to the NVDC project. Simulation results shows that it is essential to estimate the EMI level comprehensively considering the alternative of speed and DC voltage. The selected full silicon carbide MOSFET module is shown on the left figure. The parameters of the dynamic physical base model are extracted by device characterization tool in ANSYS Simpoller. On the right side is a 3D diagrammatic sketch of the traction MPC, in which the bus bar has two-layer, six-planar sheet structure, which can be recognized in the perspective. The modification of the operation state for the system will be inevitably change the operating point of the semiconductor device and the PMSM. For a project in the preparation stage, the EMI issues should be validated under different conditions comprehensively so as to provide guidance for the design of the filter. The difference of the EMI noise level between the substation should also be investigated. The figure on the left side illustrates the difference between the substation and trains in the middle of the system at the terminal of the whole railway network. It is demonstrated that the EMI noise is more significant in the trains and substation at the edge sides. Thus, the operation case of the terminal location should be taken as a reference during the EMI noise validation and filter design process for an NVDC project. An efficient device-level simulation method for EMI noise prediction during the planning stage of the NVDC transportation electrification system based on massive parallel implementation on GPU is presented. The experimental verified physics-based dynamic MOSFET model in ANSYS Symphony is adopted for an easier parameter extraction process. According to the actual structure of the MOSFET module package and the design traction MPC structure, FEM analysis is conducted and the stray parameters are extracted in ANSYS Q3D. The computation burden caused by the linear component is alleviated by hierarchical parallel architecture, which execute by a corresponding number of computation threads to attain a significant speedup. The time domain result indicate that the model has capability to exhibit high frequency oscillation during a computation of the device in MPC converters. The frequency domain result shows that the increase of the operating speed of DC voltage will lead to the side effects of the EMI characteristics, which should be taken into consideration for the project design.